In this lesson, we are going to learn how to apply the conversion factors in a systematic approach where you can convert any given measurement to another measurement of different unit. And here is the systematic approach to applying the conversion factors. There are three terms that we need to be familiar with. First is the given. In any problem, there is always a given amount of a measurement in the question. And then, of course, we are always asked to solve for an unknown values. In most cases, would be we're looking for the unknown number of a particular unit that can be solved from the given measurement, which is right here. In the process, we will use different unit. We call it the new unit that involve in the conversion factors that relate the unknown and the given together, or the other way around, which relate the given to the unknown unit. So let's look at an example. A beaker contains 3,500 grams, abbreviated by the letter G, of a substance. How many kilograms of the substance are in the beaker? So notice how the measurement 3,500 grams, that would be your given. We are given specifically, we know exactly that there are 3,500 grams in a beaker. But wait a minute, the problem asks for how many kilograms, question mark, how many kilograms of the substance are in the beaker. So the values is still 3,500 grams of substance, but we want to convert it to kilogram. So here would be your unknown. And we're trying to solve for the number of kilograms based on the given. So let's apply our systematic approach. So first of all, we are trying to solve for unknown, which is in kilogram. So we have question mark kg. And we go back to our systematic approach. We always start with the given information, which is 3,500 grams, and I'm going to abbreviate gram with G. So 3,500 G. And then here we have new unit over given. These are the conversion factors. Okay, so as well as this one. And we continue to multiply as many conversion factors as we need until we get the unit kilograms of our unknown. If we look at the systematic approach, is all relative to the unit. So first of all, we have to look at the unit of the given, which is gram. So we're going to look for the conversion factor that has gram in it. And here we have grams right there. 1 kilogram equal to 1,000 grams. 1 gram equal to 1,000 milligram. 1 gram equal to 100 centigram. But which one do we use? And it's all going back to our unknown right there. So we are looking for kilogram and gram. In this case, we are lucky because we have a conversion factor that has both the unit of the given as well as the unit of the unknown. When that happens, we don't have to multiply by any other conversion factor except for this one. But wait a minute, which one would be on the bottom? There are two parts, kilogram and gram. If we go back and look at our systematic approach, the given unit is what we start off, and we want to cancel the given unit to get our unknown unit. And therefore, part of the conversion factor that will be on the bottom of the fraction will also be the same unit as the given, which in this case it is gram. And how many do we have? Based on our conversion factor, it is 1,000 grams. So we have 1,000 grams, represented by letter G. And if this is on the bottom, the other part of the conversion factor must be on top. In this case, it's 1 kilogram, so it's 1 kg. And if we notice, we have our kilogram, which is the same unit of our unknown, and that's how we know when the. Then we move on, gram cancel out, and we can multiply this, everything on top divided by everything on the bottom, which is 3500.0. We forgot to copy the 0.0 there, time 1 kilogram. Why do I copy the gram anymore? Because the gram is being cancelled out. And then we divide everything on the bottom, give us 1,000. And there we go, we have our answer. And if we plug this into the calculator, 3,500 times 1 divided by 1,000. That would give us 3.5 kilogram. And that is our answer. So notice how we always start from our given and try to use a conversion factor that has the given unit, and then if best, it has a unit of the given as well as the unit of the unknown. Let's try another example. If I have a flask has 350 milliliter of a substance, how many liter of the substance are there in the flask? So of course our given values is 300 milliliter, which is abbreviated by ml. So this is your given measurement or given values. And we are trying to solve for a question mark liter, okay, which is abbreviated by the letter L, so question mark liter. And that is your unknown. So let's solve this problem in a systematic approach that is described in this steps right here. First of all, your unknown is question mark liter. And we start with our given. In this case, always start with your given is 350 milliliter. And time by our conversion factor. And how many conversion factor do we multiply by? It depends on the list of conversion factor that's given to us. So in this case, we know we are going to multiply by one conversion factor at least. And we're looking for our given unit, which is ml, milliliter. So here we have a few of them. We have milliliter right there, and 1 liter is equal to 1,000 milliliter. And that is the only place where we find milliliter. And it turned out that, hey, that is the unit of our unknown. So therefore, we don't have to worry about another unit. So that is the only conversion factor that we have to use, because we have the unit of our given as well as the unit of our unknown. Now the tricky part, which one will be on the bottom of the fraction, because this part can be on top or this part can be on the bottom. In this case, our given unit is milliliters, therefore milliliter has to be on the bottom as well because we want to cancel it out. In this case, how many milliliter? It's going to be 1,000 milliliter. And what is going to be on the top? Of course, the leftover part going to be on top, which is 1 liter. And notice how I use L to represent liter, ml to represent milliliter. And notice, look, ml cancel out and give us 350 times 1L, which is liter, divided by 1,000. Notice how I did not write the unit milliliter, because they are being canceled out, where liter is not. And liter is the unit of our unknown, which is the unit that we are looking for. And that's how we know that our answer is complete, because we got our unknown unit. And we plug this in the calculator, 350 divided by 1,000, and that would give us, isn't that easy? So notice again, we get our final answer with a unit of the unknown, which is exactly what we're looking for. Now let's try a challenging problem where we have to use more than one conversion factor. In this question, if a beaker contains 37 milligrams, which is abbreviated by mg, of a substance, how many kilograms of the substance are in the beaker? So here is our given, which is 37 milligrams. So G is 37 milligram. Okay, and we are looking for kilogram. That is, how many kilogram if there are 37 milligram. So question mark kg. Kg represent kilogram, and this is our unknown. So let's go back and look at our systematic approach right here. We are looking for question mark kilogram. And we always start with our given, which is 37.0 milligram. Now the tricky question is, how many conversion factors do we multiply by? In this case, let's go back and look at the list of conversion factors. Of course, we always start looking for the unit of our given, which is milligram. And here we go, we have 1 milligram right there, that's a unit milligram, and 1 gram is equal to 1,000 milligram. And that is the only place we have milligram. But wait a minute, we are looking for kilogram right here. So we have to multiply by more than one conversion factor. Since we don't have a single conversion factor that has milligram and kilogram, we had to find multiple conversion factors that show the relationship between milligram and kilogram. So for now, let's focus on this. So we know that, hey, I have my given milligram, I can time this conversion factor to get gram, okay? Because once I get gram, what can I do? I can relate gram to kilogram because there is another conversion factor that has gram and kilogram. So let's see how that works. First of all, start with our given and time that conversion factor, which is 1 gram equal to 1,000 milligram. And we know that since this is milligram, down here has to be milligram as well. How many? 1,000 milligram. And if the milligram part is on the bottom, the other part has to be on top. And notice how the milligram cancel out again. Now, the unit that we are going to focus on is the gram because the milligram just cancel out. Notice how milligrams is being canceled out and given our new unit in gram. And hence we have the new term called new unit. This new unit is the unit that is not in the given or the unknown, but is in the conversion factors or multiple conversion factors that relate the relationship between the unknown unit and the given unit. So let's see how that works. So gram is now our new unit. For the next conversion factor that we multiply by, is gonna be focus on that new unit, which is gram. In this case, we have 1,000 gram equal to 1 kilogram, and we have 1 gram equal to 100 centigram. So which one do we use? We have to go back and look at our unknown, which is kilogram. Of course, we are trying to solve for kilogram, and therefore we're going to use this one, because we don't really care about centigram. If I ask for centigram, therefore we're going to use this one. But we are looking for kilogram, therefore we're going to use that one. So how does that work? Notice how the new units right here, the new unit on the bottom, because we want to cancel out. In this case, we have gram, so therefore the gram part will be on the bottom, which is 1,000 gram. If the 1,000 grams on the bottom, the other part has to be on top, which is 1 kilogram. So we have 1 kilogram. And there you go. The new unit gram is being canceled out. Give us our final unit of kilogram, which is the exact unit of our unknown. And there you go, and that's how we know when we need to stop the problem, because it is done. We got our values for the unit of the unknown. And if we multiply, we're gonna multiply everything on top, 37.0 times, notice how I don't write the word milligrams anymore, or gram, because they are cancel out, time 1, and time 1 kilogram. Divide everything on the bottom, which is 1,000, and not including the milligram because it's being cancelled out, as well as the gram, 1,000 times 1,000. And that is our answer. And if we plug this into the calculator, we take 37.0, we're first going to divide by 1,000, enter, and then we're going to divide by 1,000 again. That's what I meant by dividing everything on the bottom. And give us a very, very small number, which is 0.00037 kilogram, and that is our answer. So we have 0.00037 kilogram if there are 37 milligram, which makes sense because kilogram is a unit that represents a very large amount, where milligram represent a very tiny amount. So that's how you use more than one conversion factors to solve for the unit of the unknown. How about you try another problem by yourself? In this question, we have a beaker containing 37 milliliter of a substance. How many centiliter of the substance are in the beaker? So again, our given is 37.0 milliliter, which is our given right there. And we are looking for the unknown, question mark, centiliter, okay, of a substance. And let's go back and look at our systematic approach, which is right here. Our unknown, which in this case it is question mark centiliter. And we are always start with our given, in this case is 37.0 milliliter. Now we go back and look at our list of conversion factor. Do we have a conversion factor that can relate milliliter of our given to the unknown centiliter. In this case, I have milliliter right here. And this milliliter is equal to liter. We don't have a milliliter equal to centiliter anywhere. So what does that mean? We have to use more than one conversion factor. But let's focus on this one first. I know I have to use this one first because it has the unit of our given. So I'm going to multiply that one. Okay? Now, if this is milliliter, of course, it's going to be on the bottom because we want to cancel out the given unit. So the milliliter part is going to be on the bottom, which is 1000 milliliter. And if this part is on the bottom, the other part will be on top, which is 1 liter right there. Now, the milliliter cancel out, give us our new unit of liter. Can we find another conversion factor that has the new unit liter and the unknown unit? Let's give it a try. Here I have liter equals to centiliter, and I have liter equal to kiloliter. Hey, there you go. We have liter and centiliter. Centiliter is our unknown, and liter is the new unit that we just get it from using this conversion factors right here. So what does that mean? We just multiply to that conversion factor. Since our new unit is liter, we want to cancel that out to get our unknown. So down here must be the same. Therefore, we have 1 liter on the bottom, and then the other part must be, where does it go? 1 liter on the bottom, the other part must be on the top, which is 100 centiliter. And notice how the liter cancel out. Voila, give us our centiliter right there, which is the same unit as our unknown. And that's how we know we are done with the problem. The rest of the problem is basically put in the calculator. But before that, we can rewrite it in a way that we say, hey, I can simplify this 37.0 times 1 from right there, times 100 centiliter. Basically, multiply everything on top, divide everything on the bottom, 1000 times 1. And if you have a hard time understanding the concept of multiplying everything on top, divide everything on the bottom, you can multiply everything on top and get yourself a number which is 37 times 100, give us 3700 centiliter. And then we take 1000 times 1, or basically multiply everything on the bottom, give us 1000. And we can simplify this more and give us 3.7 centiliter. And that is our answer.